Okay, so hello everyone. First of all, thanks a lot for joining, and thanks a lot for giving us your time. It's the most important thing. So, I hope I could like give you enough information, enough detail so that you don't feel that your time is wasted. So this time around, like we have been doing batches for, I don't know how many years now, multiple years now, and we have been giving demos out before we, start any new batch. But this time around, we thought of trying something new, that when we do the demo class, the demo class should not be just talking, something like very basics of Python, or something like that, or just telling you verbally what Python can do for you. Rather, finding out some use case and trying to build that use case within the demo class, so that although you might not completely understand the code that I'm writing, or the intricacies of the different actions that I'm doing within the demo, but at a high level you will get a understanding that what we are trying to achieve, and you know how Python can basically then, after that, getting an idea that how Python can help you in your day-to-day tasks as network engineers, right? So instead of talking about things, I am trying to demo things. And the expectation is not for you to understand, like I know you, most of you, maybe some of you, maybe 10-20% of you might have some exposure to Python. I'm not denying that. But most of you, I believe, will have very less or almost like zero exposure to Python. So I'm not expecting you to understand each and everything that I tell today or I explain today, but I will explain the use case that I'm trying to build at a high level, and then I will try to build it within the class. And as a result, I hope you'll get a high level understanding of what Python can do for you in your job role or in your area of work. Okay, so if so, I'll start by explaining the use case first, and then maybe we can go from there and talk further. And if you have any questions, you can interrupt me. But as I said earlier as well, I don't expect you to understand the code that I'm writing. But still, if you have any high level questions to ask, you can, go ahead and ask, right? And if you feel that, you know your uh, if you feel that you can contribute in some way, or if I ask some high level question to you and you want to answer, please come off mute and you can answer. So let me try to build a use case. Okay, so here what I have is a access to router, right? I have access to one of the routers. So on this router, let's say that I have a lot of files within my flash. Okay, so I've just run, it is a Cisco device, Cisco iOS router, and let's say I run the dir command and it is showing me all the files that are there in the flash. Now, one of the issues that my team is facing is that uh, what happens is that they keep whenever the time comes to upgrade the routers, they what happens is they upload new files to the flash drive on the router using SCP or using FTP or whatever. And once the file is uploaded, it sort of shows up in the flash like this, flash drive like this, or whatever drive it is on the device, it shows up like this, and it is consuming some amount of space on the flash drive, right? Now what happens is, as the device gets updated from, let's say, version 1 to version 2 to version 3, what happens is all these files, that is version 1 file, version 2 file, and the version 3 file, they all keep getting accumulated within the same flash drive. And let's say when time comes to update the device to version 4 or version 5, okay, what happens is that whenever someone tries to do a bulk upload from our FTP servers to this device, the device gives an error, okay, saying that the flash drive is full. So currently here we can see that it has some amount of bytes free on the flash drive, but in a real world scenario, what happens is that we run out of free space on the flash drive, okay, and we cannot further upload any more OS files, and therefore we are not able to sort of bulk uh, we are not able to do bulk upgrades, or we are not able to do bulk uploads, right? So what my team has asked me to do is that we want you to sort of do an audit and find out all the files that are above a particular file size. So this particular line that you see here, the third column in the output, what we see here is that the file size for iOS files, right? The operating system files are, comparatively much larger than any other type of file on the device, right? So what we want to do is we want to identify specifically these types of files, right, which have a very high size, and we just want to print out the names of those. So we are basically trying to build a script that will do an audit of all our devices, right? So I'm just starting out with one test device, which is router one, which I'm currently logged into on the screen, right? So that same device we will use to first try and get the output of the dir command, and then basically build the script further from there, and see what we can accomplish, or how we can do this audit of getting the data. And with this example, further then we will try to understand that what kind of an output I am getting from my device, okay, and it is a normal CLI output, and it is not a very structured data, okay. This looks structured, but only to the human eye, right? If I wanted my Python script to have an interaction with this data, I want to show you how difficult it is for a Python script, or what all difficulties you have to go through to build a Python script that can interact with a data set that is meant for human consumption, like it is in a table format, right? And it is not meant for machine consumption. So how we can convert this data, which is meant for human consumption on the CLI, to a data type which is meant for uh, you know machine consumption, or with which I can very easily write my logics in within code, so code can interact with the data. So we are going to also learn how to convert human readable data to machine readable or script readable data, okay. So that's the sort of the side note, or the side goal, or the concept that we are going to learn, okay, besides doing the task at hand, that is to audit the devices, okay, for unused operating system files that we can probably remove, okay. Any doubts till now in understanding this scenario, this use case? Everyone understood what the problem is and what we
Yeah,
are trying to solve? Yeah, okay.
yeah.
Okay, fine.
We are good.
Okay, nice. So, first of all, to be able to do anything, we need to be able to be in a position where we can get the data out of the device. We can sort of use the CLI of the device to pull that data out of the router. Okay. So, what I'm going to do is there are a lot of multiple options with which I can do that. But in Python, there is this concept of libraries. Like Python provides you with a lot of libraries. The Python ecosystem is basically such that a lot of people are contributing into it, and they are contributing by creating more and more libraries. What is a library? A library is someone else's code at a high level. If I have to sort of define this in one statement, it is nothing but someone else's code that you will use to solve your problems. Okay, to solve your custom problem. Okay, it is a very generic code which a lot of people can use, but you are going to use it in a very custom manner to solve your problem. Okay, so that is the definition of libraries, and we are going to use a library called netmiko. Okay, in this particular case, because since we are dealing with CLI, netmiko is a library that can sort of that is meant for interaction with network operating systems. Okay, like iOS and Junos and so on. Okay, so I'll import that library in within my script. So, and I'm not importing the whole library. I'm going to import one function out of the library, which is called the connect handler function. Now, again, as I said earlier as well, I'm not expecting you to understand everything and know everything, but we are just trying to sort of understand this at a high level. Okay, just give me a moment. Sorry, I had to take a call. Okay, so I have imported this library, and now we'll need more libraries, but I'll keep importing them as we need them. Okay, so now we're going to log in into a router, so we will need to have the username to log in, the to be able to SSH into the router, right? So I'm going to take that as an input in the terminal from the user. So I'm going to need a prompt. I need to prompt the user, so I'll use the input function, and I'll provide it with the prompt. Okay, so SSH username will be the prompt, and then I will create another variable called password pwd, which will also need a prompt, and I'm going to use a specific library which we can use specifically to take passwords, because when someone is typing the password in the in the terminal, we don't want the password to sort of get printed out on the terminal, so that no one can read it. uh, no one can do shoulder surfing. Okay, so now uh, by these two lines of code, I'll be able to get the username and password. Now what I need to do is to connect to my router 1. I need to put together some details about the router, right? So because the library netmiko requires these details to be able to connect with the device. So I'm just assembling those details. The first detail is the device type, and this is a set of custom values which you will find in netmiko's documentation. So if you're working with a Cisco iOS device, you need to provide this particular value, Cisco iOS. Okay, and then you need to provide the device's IP, which you can provide with the key host. And the value will be an IP address 92.168.25.21. Okay. And then the username, we have already defined the username in the variable user. So uh, when this line of code will run, the when I'll provide the username in the terminal, the user variable will have that value, so that will be assigned within to the key as a value. Okay, and similarly for password. Right, Fine. So in this way, I have sort of put together four important key values. The key is device type, the value is Cisco IOS, then the key is host, the value is the IP address, the key is username, this is the value that I will input when I'll run the code, and then the password. Okay, so these four details is the minimum set of details that NetMiko library will require to create a session with the device. Okay. Now, moving on, I'll create a session. And to create a session, I'll have to call the connect handler function, which we imported from the NetMiko library on top. So basically, I'm going to use that NetMiko library now to create a session, and then I'm going to further use it to also, send commands and things like that. Okay, and receive the output and so on. So we need to unpack it using the unpacking operator, and basically this is a dictionary object, and the dictionary object gets unpacked and sort of gets converted into something like this. Let me show you. So it will get converted into something like this: device type, host, username, password. So these values will get assigned to the parameters, various parameters automatically. So the parameters are on the, the left hand side, and the values are on the right hand side. Okay. Okay. So moving on. Now, what I'm going to do is I'm going to send my command using a method called the send command method, and I'm going to get my output. Okay, so my output I'll get when I'll on this session variable I'll run a method called the send command method. Okay, and the command I have to provide here. So the command is dir. Okay, so now you might be noticing few things. Okay, let's talk about those very quickly. You might be noticing that around some values, like my, the device type, I put these two uh, colons, right? This colon and this colon. And then around the IP address also, I put these colons. When I provided the IP address, I put these colons around it, right? So what are these colons? These colons basically what is the way how Python recognizes this as a particular type of data. Okay, now this is a particular type of data within Python. This is a what we call a string. Okay, it is a Python string. And how Python knows that it is a string? Because of these quotes around the text. Okay, so these quotes are important. Okay, right? In a similar way, if I just put a number and I don't put any quotes around it, like for example 134 or something, whatever number, it will be identified as a integer value. So within Python's knowledge, the type of this data will be integer. And similarly, if I were to put something like 124.3, right? So we have a decimal number here, and because of that, it sees that as a decimal, and it will be identified as a float value. Okay, so there are different types of data within Python, and there are different syntaxes that you have to take care of so that Python can identify that particular data type. Fine. Now let's come back here. I'll get my output, and the complete output that I will get will be also of the type string. Okay, just for your knowledge, I'm telling you. Now I want to see what that output looks like. Okay, so I'll print that output. So you need to use the print function to print anything. Okay, let me run this. And in the terminal, it is asking for the username, because in line number 4 we asked the Python to use the input function and get basically create this prompt so that we can provide the input of the username. Okay, so the username here is Python, And again, the get pass library automatically creates the password prompt. So we are using that. And again, the password is Python. I've typed it. I'm hitting enter. Okay. And here is the output. Okay. So end to end from here to here, this is the output. And if you want to match it with the device, you can see that it is the exact same output. Okay. So we have that same vios file and the size and so on. Okay. 148.955.508. Okay. Clear? You can match it. So we've first, like one subtask is done here. And what we have been able to do till now is receive the output from our device. Now, if we go back to the original request that we had, the request was to basically identify all the files within the flash that are above a particular size value, above a particular number of bytes. Okay. So if they are above it, most probably they are a iOS file, because we don't have files larger than that particular value, in general, right? Only the iOS file exceed a particular file size by a big margin. Like this is, I think, what uh, if I talk in Indian terms, or US terms, it is 524,000 and 288, right? And this one I think is um, 148 million 955,508. So this is like much larger in file size compared to any other file that we have on the device. So from this we can sort of recognize that this is a iOS file. Guys, please make sure as you're joining, your mics are on mute. Okay. Uh, if you have to ask a doubt, you feel free to, unmute yourself. Okay. So till now, what we've been able to do, we have been able to
Amit,
extract the.
I have a
Yeah.
doubt.
Yeah, please.
How Python is connecting to secure CRT then to the device?
It is not connecting to the secure CRT. Okay, so there is no secure CRT here. The secure CRT is just, I have the console connection to my router. It is from the GNS3 topology. Okay, I have a GNS3 topology running, and this is the router that we're talking about. I double clicked on it and I opened the console connection to it. Clear? It is not
No,
connecting to the.
I mean to say how the Python
Hmm.
program is.
Yeah, yeah, yeah. Good. Good question. No issues. So what is happening here is, like, what happens in the case of secure CRT? What is secure CRT doing? Secure CRT is acting as a SSH client, right? And the router is acting as the SSH server, right? In the same way, what NetMiko library does is that for the time being, your Python script is running, it is going to make your Python script itself as the SSH client. Okay, that is what it does when we create the session variable. Okay, when the session variable is created, at that point it has an active SSH session with the device. Okay, so your Python script itself is acting as a SSH client. It is not using secure CRT anywhere in between. Clear?
And that is done through this connect handler function.
Yes, yes, yes. Which comes from
Okay.
the NetMiko library. So
NetMiko. Okay.
NetMiko library is where all this code is written of how to make it an SSH client.
Got it.
Hmm. And that is the power of, like, that's a very good question for another reason, because now you also realize that within Python you get access to such good libraries that probably within 2 or 3 lines of code you have an active session with the device. Okay, now just imagine if you were using some language where such libraries did not exist. So in within that language, you will have to write, or your maybe your company will have to put together efforts to write the whole code to sort of just come to the point of creating an SSH session, right? It will have to take care of the TCP session creation. It will have to take care of like that three-way handshake and all those type of things, and then it will have to take care of all the encryption related stuff, and then it will have to take care of the ability to encode data to send into the session, decode data, whatever comes from the session, and all those sort of things, right? All those complicated things. Now in this case, all that is handled by the library itself. That's another important thing to know about Python, that it gives you with so much power. Okay. How much code did I write? Like if I just count the number of lines, two here, one here, three, and four, five, six, seven, and I would consider this as one line. So 8 lines. I had to just write 8 lines of code, and I was able to get the command output. You see? So that's why Python is becoming so popular. And most of the code, if I like give you basic understanding of syntax in a few days, you will be able to very quickly understand what I'm trying to do in the code. Okay, maybe it's your first day, you might feel that it is very hectic to understand this, but if I like walk through with you some of the important concepts in maybe 10-15 classes at max, you'll be able to understand what is happening in the code very quickly. So that's the power of Python. Okay, now moving on to our use case. uh, you know Now let's say this whole output that I'm getting, it is one single block of text. Okay, for Python. For us, we know as humans, we can read it and we can see that every single line, like it is sort of, it has multiple sections within it. It has like the first column, then there is a space, or what we call in English as delimiter between the columns, so that we realize that okay, one column has ended and the second column has started, so they are putting some space in between, right? And then we can see the third column, the fourth column, the fifth column, and the sixth column, and the seventh column. So within this output, like there are two pieces of information that I'm interested in, right? That is column number three and the column number seven, the last column, right? Where the column number three is where I'm getting the size of the file, and the last column where I'm getting the name of the file, because these are two important data points within every single line that I should be able to somehow grab out of the output, so that I can write my logic. And my logic will be to basically check the size of the file, whether it is above a certain value or not. And if it is above a certain value, I will have to sort of identify that file, or sort of in some way filter it out, or just print out the name of the file when my condition that it is above a certain file size is met. Okay, so that is the logic that I'm trying to write. So before I can write that logic, I have to write another logic where some way I need to be able to identify or extract these two data points out of the whole output for every single file, right? That is the file size and the file name. Okay, so I need to write that code first. So now, since this data is meant for human consumption and it is not for machine consumption, I have to do this extra step. Okay, that is to use some logic to be able to extract those data points. Okay, whereas if there was some like if I would have got that data in a more structured way, I'll tell you what structured way looks like. Like this is an example of a structured way. It is what you call a Python dictionary, right? So somehow just imagine if instead of getting this data, I would get the data something like file name equal to this, file size equal to this, and date of creation is this, and other details, right? So if I were to get all my data in a more structured fashion like this, it would, because this type of data structure is meant to be worked upon with Python, and it is a Python data structure, I can very easily work with this data. Okay, I can use operators like this, which will sort of, which in this case, as you saw, can convert that whole dictionary into something like this. And I had to just put 2 stars. Okay. So all this capability comes when I'm dealing with a Python data structure, not when I'm dealing with a block of text. Okay. Because this is just a block of text for Python. Okay. It is a string, multi-line string. Okay. So somehow I need to be able to convert that data into this. But for now, we are going to do that part later. But for now, I'm just going to show you how to grab important pieces of information out of the whole block of text using something called regular expressions. I'm pretty sure as network engineers, knowingly or unknowingly, you have been using regular expressions. Uh, I would say almost daily. Okay. So, for example, any show command that you run, okay, if in the show command, let me show you, like if in the show command, let's say I have this command show IP interface brief, okay, so I'm seeing that there are few lines that have IP addresses unassigned. So this is a particular pattern that I'm seeing in few lines which I don't want to see. I don't want to see any line that has unassigned pattern within the line. So what do I do for that? I used a regular expression, and in which I'm saying exclude all the lines that have the pattern unassigned in them. So this is an example of using regular expressions. So knowingly or unknowingly, you are using regular expressions in your day-to-day tasks, right? And on top of that, like there are certain instances, like if anyone of you has ever worked for, ISPs, and specifically, worked on provider edge devices, which are which are connected to other ISPs, NNIs and stuff like that. You have EBGP sessions and all. If you worked on those sort of devices, you might have used something called an AS path access list, right? So AS path access list specifically uses regular expressions. Like you will have to learn the whole regular expression language and build those regular expressions, right? So I'm not going to teach you completely how to build a regular expression that will match on this whole line. I'm just going to build it. Okay. And I've already built it. So I'm just going to use it, but I want to show you that regular expressions can be something very tough to deal with. Okay. So I have a regular expression already built, right? So let me just put it here. Okay. So I'm calling this DIR-RE, or DIR regular expression. And this is what that whole regular expression looks like. Okay. Now, if you understand regular expression language, I'll quickly explain. So like as you can see in the beginning of the line, I have space characters, right? There are spaces. So to match on one or more spaces, you use the slash small s plus. Okay. Then I have a number, right? The first thing that I hit on in different lines is a number. And in some cases, the number is small. In some cases, the number is big. So I just use slash d plus, which means match on one or more of numbers or digits. Okay. In RE language, we call them digits. Okay. Or D. Then I have again some space. So slash S plus. Then I have some more characters. I'm not interested in them. So I'll just call them slash capital S plus, which means match on any non-space character, and so on. Okay. And then out of that, I'm interested in two data points. That is this, the file size, and the file name. So around these two characters, what I've done is I have put brackets to make them a specific group. Okay. So I'm trying to not get too much into detail. Okay. Because I'm understanding that I understand that probably 90% of you won't be understanding what I'm saying here. So no issues if you're not understanding. Within the course, all these things are covered nicely. So I'm pretty sure after you're done with the course, you'll understand everything. Okay, so for now, I'll just write the logic such that I can, you know, I can go line by line in the output and extract extract these two details. Okay, so uh, I'm going to use the RE library. Now I'm using the RE library, but I haven't imported it, so I'll have to import it on top. Okay, and then I'll go ahead further and say that my pattern is equal to dirre, and my string on which I have to do the match is within the variable line. Okay, in individual line, right? If there is a match, because there will be some lines like this one where there will not be a match, because this RE pattern is specifically meant for these kind of files, these kind of lines, I should say. Okay, so if there is a match, in that case, print in a specific way, print first, I want to print the file name, right? And that will be in the group 2. Okay, and then print the file size, and that will be in group 1. Okay, so yeah, so let's just run this code again. This time I don't want to print the whole output, I just want to print the extracted output. Okay, so it's asking for the username, password, and I have some data that is sort of more filtered out of the whole output. Okay, I have access to individual file names and I have access to their particular file size. Right now, this output does not look very readable. What I'm going to do is I'm going to sort of adjust this and put empty spaces for any file name which is shorter than a particular length. So we use a method called ljust, which will adjust the file name with empty spaces and make all of them 30 characters long. Okay, now when I run it again, this time output looks more readable. Okay, so and this is just for readability purposes. We don't need printing out everything once we are done with writing our logic. Okay, it is just to show you that we can print out like this, like file name, file size, and so on. Okay, now the whole output that we got, here on top was in string format, and even the file name and the file size, all these are also in string format. Okay, so if I want to write a logic and see if if the file size is greater than a particular value or not, I will have to convert it into an integer. Okay, so I'll create a new variable called file size, which will be equal to this value m dot group 1, but I want that value in integer format. So I'll use the integer function and put that as an input to the function, and I'll get the value within my file size variable in integer format. Okay, and then also my file name, which I don't need to convert. It is simply this and this. That's it. Okay. So I have the file name and file size. Now what I can do is I can write the logic that if file size, okay, is greater than or equal to, or maybe just greater than, okay. So what I'll do is I'll copy this, okay. I need to find some value that works out for me. So I don't want to put it equal to this. What I'll do is I will probably uh, convert, how many are these? One, two, three, four, five, six, seven, eight. So I'll just convert that into eight zeros. Two, three, four, five, six, seven, eight. Okay. Or maybe seven, because I know, any other file is not even going to be that much high, right? So I'll just take that value and I'm going to print the file size only in, I'm going to print, sorry, the file name I should be printing. I want to print the file name when that particular file's size is greater than this value. Okay, fine. So let's run this and see what output we get. Again, Python. Now, if you'll see, I'm getting the whole output because we had this print statement in it. But you might notice that this time for one particular file, we are getting an extra output, an extra printout. Okay. So basically, our code is successful. The logic that we wrote here is successful. Okay. Now you might be seeing that the logic itself was not that big. It is just two lines. But reaching to a point where I have the file size, I have the file name to be able to build this logic, that itself took a very long time. Okay. I had to write a lot of code. I had to have an understanding of the regular expression language, right? So that itself took a lot of time. Other than that, I was pretty good, right? The logic itself was not that hard to build. Okay. So, so what I'm going to do is, first of all, let me also show you that if I remove this print statement and run the code, I will only be able to print the file name which has a size greater than this value. Okay. So, the logic that we set out to build, I think we've been able to build it. So anyone has any doubt till now at a high level? You're all understanding what I'm trying to do here?
Hello, am I audible?
Yes, the logic is clear. Some of the
Hmm.
functions that you're using, like the groups that you're using, and how you have
Yeah.
imported the regular expression directory, I think that's going to take some time.
Yeah, that's obviously, yeah, you're right. So,
Hello.
yes.
Yeah, I have a question. See, we are doing it automate, right? So again and
Hmm.
again after the running, you are giving the password manually. That could be not
Hmm.
scripted.
Yeah, that's a very good point. Even I'm irritated by that. So what I'm going to do is, I'm going to comment these two lines. I'm going to copy them, paste them, comment these ones, and I'll make it Python. I'll basically I'm providing it a fixed value. Okay. And now when I run this, I don't have to do anything.
Nice, nice.
Okay.
Yeah.
Yeah. So generally, it depends. Like if something, if you are building a use case or if you're trying to do a task where, let's say, your script has to log in into, let's say, hundreds of devices. So, In that case, it is still fine if someone inputs their username and password one time. But let's say there is a scenario because of which someone will have to input multiple times. In that case, what people can do is you can store your username password. It is not a good practice to store them in the script itself. Okay, but you can store them in some other files that is local to their PC, and you can build the code such that it will go to that location, it will access that file and read it from there. Okay, so all these things can be managed basically. Okay,
Got it.
yeah. Anything else?
We are good to move next.
Okay, okay, great. So now I hope I was able to like make you all understand one thing, and that was the problem with getting your data in CLI, right? So the CLI data from the perspective of your Python script or from the perspective of a developer, it is not structured data. Okay. And just because like someone like me or maybe someone like you knows regular expression and they were able to build that regular expression, and it is not a very easy regular expression. Like before this class I was building this. Okay, like it took me probably, I don't know, 3 or 4 retries. I made mistakes while writing such a long regular expression, and uh, I made like it took me multiple attempts to get it right. Okay, because it is very big, right? So that's not what you should be doing generally. Okay, so like there are multiple solutions to this. Okay, the first solution that I want to talk about is a library called textFSM. So this problem that we are facing, back in the day, even Google faced the same problem. Okay, so what Google did is they created something called textFSM. Okay, as you can see, Google has their own account on GitHub, and this is one of the open source projects. Like the code is available for anyone to see and use. So they created this library called textFSM. What this library allows you to do is it allows you to create something called textFSM templates. Okay, now, what are these templates? Now, in the background, even these templates use regular expressions. Okay, so so you're not completely getting rid of regular expressions with this particular approach, but it eases a lot of things for you. Okay, in many ways. So let me show you a sample text FSM template. Like within this, there are some examples you can see there as well. Like there is a Cisco BGP summary example, and there is a Cisco BGP summary template. Like a template looks somewhat like this. Okay. So for like if you have the show IP BGP summary command, which looks somewhat like this, the template for that same command looks somewhat like this. And all the important details like router ID, local AS, remote IP, uptime, received V4 routes, the status, all these things can be extracted. And what this template enables you to do is it will convert that data into a more structured data. Like it will convert it into something called a Python list or a Python dictionary. Okay. So these are more structured data with which Python can very easily work. Okay. Python can like it gives you data in a structured way, and you can very easily write your logic then. Okay. Now, similarly, what happened is there is another company called Network to Code. Okay. Now, what they do is they are into network automation business. They do automations for a lot of companies and things like that. They have their own products, and even what like they did is they created this repository on GitHub, which is again open source. Anyone can read it and use it, called NTC-templates. Okay. So within this, what they did is they like it is not just them, like a lot of other people are also contributing to this. What they are saying is that use a particular nomenclature, that is the name of the vendor, then the name of the operating system, and after that the name of the command, and then dot text fsm. Okay, so if you use this particular nomenclature, you can you can create a file which will have the text FSM template for you know converting the output of that particular command mentioned here into more structured data. So here, if I go down, this is all A for Arista, B for Broadcom, and then we'll have C for Checkpoint, Sienna, Cisco. Okay, and within Cisco we have ASA, then iOS, and then within Cisco iOS we have this command dir. So someone, what they did is they already created a text FSM template for the dir commands output. Okay, now what I had to do as a network engineer, obviously I could have created my own, and there is a lot of literature where I can read and understand how these templates are created. But what you will realize that within the template also they are mentioning regular expressions only. But this is a much more simpler regular expression compared to what I had created in the script, this one. Okay, on top. So it is a much more easier way of using regular expressions. Okay, so where you're assigning smaller portion of the regular expression to a variable name, and and you're basically sort of creating it in a very simple way where you're putting these variable names to create your individual line instead of creating the whole regular expression in one go. Okay, now we are going to use this. Okay. And what NetMiko does is it allows you to use textFSM. So this whole code that I created up till this point, I'm going to, we don't need the RE library anymore. So, you know, uh, I don't need that regular expression anymore. I'll get rid of that. We don't need this also. I'll get rid of that. And here, you just need to provide one extra parameter, that is use text FSM equal to true. Okay. So what happens now is what I did to be able to use this particular functionality, I had to sort of go here, go to the NTC templates project library, and I had to download this whole repository locally. Now, where did I download it? Let me quickly show you. Within my PC, there's this users folder. Okay. This in the local disk, I have the users folder, and within this, I sort of downloaded it. I downloaded it as a zip file, and I unzipped it and placed it at this repository. This is my current user, and within that, I placed it. So if you'll go inside, you'll see the same structure, and all those text FSM templates are mentioned here. Okay. So I didn't do much. Like there would be cases where you want to convert a certain command's output, but that command you are not able to find in that repository. So in those cases, you'll have to create your own text FSM templates. But trust me, it is still easier compared to creating your own full regular expression. Okay. Now coming back, this time I'm just saying use text FSM equal to true, and NetMiko library will automatically be able to locate that repository on my local PC in the users folder, and use because it is a Cisco device, because it is iOS, and because this is the command, it will be automatically able to determine which particular template to use. Okay, and it will use it and give me the output in a more structured fashion this time. And when I print the output, you will see the difference. Okay. Let's run this. Now, you might look at this and you might feel, is it really structured or not? Okay, so let me print it even more nicely. So I'll use another library called pretty print. Okay. And instead of simply printing it, I'm going to pretty print it. Okay. When I run this, now you can see the output in a much more like nice, understandable fashion. Okay. Now, every single line in the output has been converted into a Python dictionary. Okay. Now, the first file that we were seeing, boot. Okay. Let me relate it with the device. So this is the first file. So this is the first line. You can now see that first line, how it has been converted into this. So it is showing you the date and time of the file. It is showing you the file system, which is flash 0. Then it is showing you the ID, this one, ID 1. Then it is showing you permissions. It is showing you the size, which in this case is 0, right? Then it is showing you the free, like the total free bytes and the total bytes, right? So total size and total free size, all like for every single line, it is giving you all these details. And similarly, we have this particular file, this particular dictionary. Okay, so what this data looks like, it is a list of dictionaries, and every dictionary represents one line in the output. Okay, now what happened because of that? Now I know that the output variable is a more structured data. So what I can do is I can directly write my logic. I can say for, because every dictionary is representing one line in the output, I can create my variable called dict, or a dictionary which represents a line, for dict line in my output. Okay. The size, or I should say file size, is equal to, within that dictionary of line, there is this parameter size. Okay. And the file name is equal to, within that dictionary, is equal to name. Okay. So let me show you, first of all, a normal printout. File size, comma, file name. Okay. Let me run this. I should have commented this, but I think it's okay. So here, from here to here is what this print line achieves. Okay. I can now uncomment this line. I don't want to see that whole printout again and again. Now, what I can do is I can use that same logic. Okay. Comment instead of deleting. That same logic which I used here. This one. Okay. Okay. So if now again here as well, the size value, the file size value, where did it go? Is also a string, by the way. You can see the quotes around it, right? So here as well, I'll have to convert it into, sorry. I'll have to convert it into integer to do that comparison, but that's not a big deal. Okay. And here as well, if I run this logic, I'm again able to extract the name of the file, which is above a particular size. This one. Okay. So what did we achieve in these two scripts? We achieved basically the same thing. We were able to identify the file name which was above a particular size, although we were not able to build that whole audit script and everything. But we till now have been able to build the logic that achieves the same thing, but you can compare the amount of effort which it took for me to do this versus what it took for me to do this. Okay, now don't compare the number of lines, also compare the effort. Okay, the effort is much less, as you might have realized, because just using this one small piece of code here or one small parameter here, which I enabled, it automatically converted that whole data into a more structured data. Okay, and in this data I'm getting even more details. Like I'm like there I was just able to get the particular file size and particular file's name. Here I'm getting other data points as well. So if my use case required me to build an extra logic where let's say my team also wants to make sure that the total free size that is available on the file system is enough to be able to upload a new iOS file that is of particular size. I can verify that as well because I'm getting that data point as well. So if I had to achieve that task through this, I'll have to write another regular expression for that particular purpose. Okay, so that would have been another uh, maybe another hour or so to build that logic from ground up. But here that problem is already solved for me. Okay, and that is the difference between structured data and unstructured data. Do you understand? Yes. Any doubts, guys? Anyone before we proceed?
No, I think we're fine. It's just that
Okay.
it's going to take some time to absorb all this thing because
Yes.
we're seeing this for the first time. All
Yeah.
this thing is going to be in text
Yeah.
FSM or the net code or whatever that you mentioned, right? We haven't
Hmm.
seen that before, so we need to first understand what that
Yeah.
does, how to incorporate that into the code. So right now you're
Yeah.
just using it in. So
Yeah. But I hope you're also able to sort of realize, what as network engineers you can do with this, right? I hope you're able to realize that as well.
yeah, definitely. Yeah,
Yeah.
you have built a pretty basic use case, and then you're showing us how we can
Yeah.
get this information. So this is just one example. There will be tons of others,
Yeah.
but the flow we can understand.
Yeah. Now let's go a step further. Okay. Now imagine what if your devices could directly provide you structured data. Okay. Now our devices, now I have another device in the same topology, which is a Cisco's CSR router. Okay. Which uses iOS XE. Okay. It is a CSR router. Okay. And if I do show version, you would be able to see that it is a iOS XE software. Okay, it is not the general iOS software, it is the iOS XE software. Now, this iOS XE software has some additional capabilities. Okay, and I'm pretty sure a lot of you might be using other models except CSR, like you might be using ISR routers. Now, CSR is a a cloud first kind of a router. It only has like virtual images, virtual iOS images, but you might be using ISR routers in your networks. Okay, or similar, lot of other new models have come out now, which also use iOS XE. Even new switches that are coming out from Cisco use iOS XE. Right now, this iOS XE platform has additional capabilities. Those capabilities are called netconf and restconf. Okay, so basically, today I'm not going to talk about netconf because I don't want to complicate things. Okay, overcomplicate things. I don't want to scare you, but it also has additional capability called restconf. Now, what this restconf does is that it opens another port on the router. Like till now, if you are like normally SSHing into your router, you can. It also opens, like in that case, in the case of SSH, it will be port 22. But in the case of RESTconf, it uses the port 443. Now, where else have you heard port 443? Anybody?
Yeah, HTTPS.
HTTPS, right? So it opens the ability to use HTTP or HTTPS kind of connections. Okay. So this whole router basically gets converted into a type of web server. Okay. And instead of supplying the CLI output to you, it can supply the output in a more structured fashion, like how general websites work. Like you get your data from any website in a more structured fashion. You get HTML, or you get JSON and all these languages in return, which are basically readable by programs like browser and stuff, and easily workable, and because of which those websites can be nicely sort of presented on your screen within the browser, right? So some similar kind of a capability, like obviously it is not a full-fledged website that it is going to create, but it is going to create something called it is going to enable something called REST API on top of the device. Okay, and you'll get the capability to access your device in a using port 443, as just like you access any other REST API. Okay, so now I don't want to write this whole code and waste your time. I've already written it. Okay, so I'm just going to show you. Actually, let me get portions of this code for you, and we create a new file. Yes, 5. Actually, I have a file specifically for this one. Okay, I ended up just a second. I should have put this in this file. Maybe this one. Okay. And here I'll put the code for restconf. Okay. Now, this code is sort of written using something called Python functions. Okay. So, you know, uh, don't get into the, will obviously in the course, the topic is covered how to create your own functions. But here, I'm not going to talk too much about that. I'm just going to show you what sort of output we get. Okay. And one more last section. Code. Okay. Now, as you can see, The IP address is 25.23. Just to verify very quickly, if I do show IP interface brief, this router has that same IP 25.23. Okay. And the port is 443. Username and password is again Python and Python. Right. And as you can see, for this particular router, I'm having a URL this time. Okay. And it has that HTTPS in front. Then it has the host, which is going to be this value, basically put inside finally coming from here. And the P will be equal to the port number, which is equal to this value, right? 443. So I'm going to sort of access a particular URL, and I'm going to require some specific headers. I'm going to send a GET request with that URL mentioned here, with the username and password, with the headers. And this is basically, I think, verification that happens when you open any URL. So I'm just setting it to false, that I don't want to verify. If like the certificate verification part, I'm setting it to false, that I don't want to verify, because I know it's my own device. And anyways, it just creates a lot of errors and things like that. You'll have to basically have a copy of the certificate locally to be able to verify and all that all those things. So we don't want to get into those, just say false. Then I am going to get a response. Now that response, any response has a status code. If it is a successful one, it is 200, and I'm going to get a text in the response. So that text I am going to put inside this variable interfaces. And let me show you what that text looks like. And then I'm going to show you a more sorted sort of format of that text. Okay. Let's run this and let's see. I also want to show you the speed of this whole operation compared to what we were doing with CLI. Did you see? Did you notice how quickly it went compared to the CLI? Like, let me run it again. I'm hitting enter at 3. 1, 2, 3. And output is here. You saw? Okay. I hope you saw that. So basically, this sort of an interaction is very fast as well compared to CLI. So CLI is generally in the background are converting whatever data points you provide in the CLI to some other format, whereas this format is very close to that format which is on the device already, where how the device's database is sort of also aligned with this format, and that is why this operation is very fast compared to the CLI operation. And what do we see here is that I'm getting my interfaces data in a more structured fashion this time. Okay, this is the response.text, and this is that same response.text converted into Python, Python dictionary formatting, and that is why the printout looks like this. Whereas this is something you call JSON. Okay, so I'm getting my data when I did that API request. The response was JSON data. Okay, and JSON data is much more structured, and this is what the data looks like. I'm getting all my interfaces. I'm getting the name, their description, the type of the interface, if it is enabled or not, what is the IPv4 configuration, what is the IPv6 configuration on the device, and so on. Okay, just by using a particular URL. Now you might be wondering how I came up with that URL. So there is a lot of documentation that you can read and get to know how to build this URL, these URLs, and so on. Okay, but we'll not get into that. We'll be discussing that in the course. So, this is already structured. That's what I'm trying to focus on. So now you can write logic very easily on top of that. Okay, like I have some logic that I've already written, although this logic is just to print out and you might feel what's the need for it. But let's say if I had to build a logic or identify the interfaces that sort of are of particular type, or if they are enabled or not, any sort of logic I wanted to build, if they have an IPv6 address or not. Let's say I have to build an application, or there's a request saying that we have to apply IPv6 interfaces on all the interfaces that are enabled and have an IPv4 address. Okay, so for those kind of scenarios, if I'm already getting my data in such a structured format, the logic will become very easy to write. Okay, whereas if I had to do it using CLI, I don't know how many lines of code it would require. Comparatively, it would be very large. Okay, and even then I'll have to sort of build my logic. So here the logic is just to sort of print it out in a nice way, like a CLI. So let me do that. Okay, so I'm just writing the code of printing it out, so don't
So
worry.
when you're writing this, are you requesting the entire code right now, unlike what you were doing before?
Can you come again? I didn't quite.
When you're using this HTML format, right? Are you requesting the
JSON
entire?
format.
Yeah. So, but in the JSON format, are you requesting the entire code, unlike before when you were only using the output of a particular command?
Good point. So I'm just getting a particular data point. Okay, I'm not requesting the whole, all the data that is there on the device, right? Like if there is OSPF data, BGP data, or any other type of data, I'm not getting all those things. I'm just getting the interface data, and that too, like there's another concept called Yang models here that is being used, which we haven't discussed. So in that concept, like I'm asking the data for a very specific container, the configurational details, like the details that you can configure on the interface. Like within the interface data also, I'm getting a sliver of the information. Okay, a very short piece of the information. Got it?
Okay. Yep.
Yeah, it's not the whole thing. So yeah, so that is where like you'll need to understand how these URLs are built and what or the other details within the URL. Okay. So yeah, coming back to this, let me sort of comment these lines so that you don't see that big output. So here is the same sort of similar to show IP interface brief, but using the API this time. Okay. And you might have noticed the speed of this operation. Okay. Right. So yeah, so that's what I wanted to discuss today. And I want to show you that what's the, like if you are getting unstructured data, how to convert it into structured data, specifically in the case of, device CLIs, uh, and what are the possibilities if your device can directly send you more structured data. So I hope at a high level you were able to understand all these details. So I'm like sort of leaving last 9-10 minutes for any questions that you might have, and then we can close the session. Yeah.
Right. So the first thing that I want to check with you is during the course, right? So you kind of showed in today's class how to go step by step. What are the different ways, and eventually we use uh, the URL format, how to pull the data, and then probably you'll be taking action based on that.
Hmm.
So is that how the final goal is going to be, that we will be learning how to get this through these particular URLs, or
Hmm.
is it going to be a
No.
combination, one or the
Uh,
other?
yeah. No, the goal is not to sort of show you device capabilities, but rather to show you what are all the different options available to us
Mhm.
as network engineers, right? Because like when I say use Restconf, like in your production network, maybe your company doesn't even allow you to open port 443. Okay, even
Mhm.
if your devices have that capability, like all Juno's devices and all the modern Cisco devices have that capability, but maybe they'll not allow you to open port 443 or HTTPS capability, or even for that matter, netconf capability, right? Which uses another port called 830, right? Even in that case, you get more structured data in XML format, not JSON. But like these are all sort of organization level decisions. But what if you work for a company where this option is available already, like any of the hyperscalers or like AWS, Facebook, all these like forward looking companies for like ahead of the curve, all these companies already have these options enabled, right? So what if you get an opportunity to work for a company like that? So, you should know what to do when you get structured data or how to get structured data from the device, right? And in the other cases, where you're just getting your plain old CLI to work with, even in those cases, what options are available, how much of automation you can do in those scenarios. So my job is just to show you all these options. Okay.
Okay.
Yeah.
And we'll be using all these today. You use multiple options, right? And you said
Yeah.
that based on what company you work for, what options are available. So are
Mhm.
we going to learn all these different options, or is it going to be uh, one option or the two
No,
in this?
primarily, you have, I would say, what, three or four options today,
Mhm.
right? Uh, that
Yes.
is that is like CLI itself, like obviously can be accessed using Telnet and SSH and console. So I'm counting CLI as one option, right? No matter what is the transport, you're going to get the CLI data. So that is one option. The second option is netconf, okay, which also uses the SSH transport but uses a different port number. The data that you get there is also structured, it is XML. So you will be learning about that and how to work with XML data, how to extract important information out of XML data, right? So those things we'll be learning. And the third type is RESTconf type of transport, REST API, how to enable that, how to get data through that, how to work with that data. So that data basically primarily will come out in JSON formatting. Okay, as this one. Okay, this is a JSON formatted data. So how to work
Mhm.
with these types of data. Then, uh, when you work with, like most of you might also be working with control points or controllers of different sorts, right?
Mhm.
Like some of you might be working with Viptela, vManage, right? SD-WAN. And some of you might be working with some Juniper controller, I don't know. So even these controllers have northbound APIs. Okay, like DNA Center or all these controllers pretty much have REST APIs. So we'll be tackling one of the controller as well. Like in the course, I've taken the example of vManage SD-WAN.
Mhm.
Okay, but that same concept is very easily replicable in other places. Okay, so we'll be learning that. So all these options, and based on these options, there are some use cases that or some examples that I've built in to teach you the concept. Okay, so those will be going through those things in the course. Is it clear?
Yep.
Any other doubt?
Not related to the program, but in
Hmm.
terms of the practice, right? So
Hmm.
will we be, I know you're using JNS 3, I guess. So
Yeah.
will we be able to access any of these? Do we
Yeah,
have
so
access?
there are two options that are available. You can access the lab provided by us, but in general, I urge people to, create their own lab. This sort of a lab does not require a lot of RAM. Uh, but in some cases, people are using official laptop, and let's say if some company doesn't allow you, there are those sort of companies as well, rare, but there are. So in that case, you can access our labs. But I would still like promote or urge or recommend to use uh, your own lab, because once you've done created your own lab and learned how to create your own lab, it will help you in future as well, right?
So will there be any help for us or guidance how
Yes,
to
yes,
build?
yes, yes, yes. You'll get a different set of 6 to 7 videos to create this topology on your own PC. Okay.
Okay.
Yeah, and still, if you get stuck, there is always class. You can join in, and I can help you with it.
Okay.
Anything else? I think you can contact the team for getting to know the timings and all those things. Okay. It will be a 2 day class on Tuesday and Fridays from 8 p.m. to 9:30 p.m. India time. Clear?
Okay.
Okay,
And
guys.
when we are going to start this batch? Any idea?
I think uh, as soon as next week, I believe Tuesday. Yeah, I'm not wrong. The other option could be the week after that. That's it. Not more than that. Okay.
Probably in July only, right?
Yeah, yeah, within July. Yes, yes, yes.
Okay.
Very
Good.
good chance it will be the coming Tuesday. Okay.
Okay.
Yeah,
It was a nice session, Amit.
yeah. I hope your time was nicely
Yeah,
utilized,
obviously.
not wasted. Yeah. Okay. Thanks a lot, guys. We'll end the session now. If you have anything
Thank
else
you.
to ask, please shoot. Otherwise, we can end it.
Thank you so much.
Thank you.
Okay. Thank you.